Today we will discuss on hydrogen embrittlement. Before we go in depth, let me discuss what is the meaning of the word embrittlement. The meaning of the word is actually a process in which ductility of the metal is significantly reduced, due to which the metal will become brittle. And therefore, if a metal or a metallic structure loses ductility because of any reason, the metal or metallic structure will become brittle. And therefore, the phenomena in which the metallic structure or metal become brittle due to the induction of hydrogen is known as actually hydrogen embrittlement. This phenomena is also known as hydrogen assisted cracking, or in short it is HAR, or hydrogen induced cracking, that is HIC in brief. Sometimes you may see the term HAR or HIC are written in place of hydrogen embrittlement, because this type of embrittlement is caused due to hydrogen assisted cracking or hydrogen induced cracking. In brief, they are also represented as HR, and the HSC cracking represents C, and HIC hydrogen induced cracking. Actually, this phenomena explains embrittling of a metallic structure when it is being exposed in hydrogen environment. I repeat, a phenomena when a metal or metallic structure is being exposed in hydrogen environment, this type of corrosion may take place. This is a very complex and very poorly understood phenomena because of variety and complexity of the mechanism, due to which embrittlement of the metal or metallic structure takes place. Now, as we know that, how automatically something will come in our mind, how hydrogen can be introduced in a metal or a metallic product. As all of us know that hydrogen can be introduced in a metal or metallic structure during manufacturing operation. There are so many operations where hydrogen is being used, like pickling, coating, packing. There are so many phenomena where actually hydrogen is being used. Hydrogen can also be introduced by over time by environmental exposure to soil, chemical and water, during which caustic embrittlement can take place. Now we have to see what are the important points which will determine this serious type of corrosion, that is caustic embrittlement. Let us see. 3 parameters are there. Number 1, pressure and hydrogen diffusion. Number 2 is susceptible material. And number 3 is stress. These 3 parameters are essential for this type of corrosion. Number 1, presence of hydrogen is a must, and diffusion of hydrogen has to take place. And material to be susceptible, material we are going to use is to be susceptible to hydrogen diffusion. And number 3, the metal or metallic structure which is being exposed in the hydrogen environment must have stress. I am referring to internal stress or external stress. Internal stress, you know, it is actually tensile stress or residual stress, and external stress when we sometimes use externally, like welding. Now let us talk about the different mechanism involved in it. it is believed that, as I have told you earlier, it is a very complex and not completely known phenomena, but different kind of mechanisms are proposed, out of which we will discuss a few of them. Let us start with, these are the proposed mechanism. Number one is internal pressure. Number two, metal hydride formation. Number three, enhanced discohesion. Number four, localized plasticity. And number five, vacancy formation. These are different actually mechanisms which are proposed by scientists to explain hydrogen embrittlement. Let us start with one, internal pressure. Suppose you have made a structure of any particular metal which is fortunately unfortunately exposed to an actually hydrogen exposure, and due to which hydrogen may be adsorbed on the metallic structure or metallic surface. Now this hydrogen will combine together to produce molecular hydrogen. As a result, they will start creating or rather exerting pressure from inside. Now this pressure can go up to that level that the ductility, toughness and tensile stress of the metal will go down, resulting cracks. This is one mechanism which is proposed. Number two is metal hydride formation. As I have told you, if a metallic structure is exposed to hydrogen environment and if its hydrogen is absorbed, there is every possibility the brittle metal hydride will be formed, as a result of which this brittle hydride will go over the entire metallic structure, making the entire structure brittle. And this is another actually mechanism which is proposed. Number three, enhanced decohesion. As we know, when a metallic structure is formed, there remains a very cohesive attraction between the atoms within the metallic structure. But if hydrogen is adsorbed, it will enhance decohesion. I try to understand. Cohesion is good bonding. Decohesion means it will break the good bonding between atoms, due to which your metallic structure will become weak, and with time cracking and different kind of problem may appear. Number four is localized plasticity. You know what is plasticity? Plasticity is the property of a metal due to which you can make any shape of that metal and it can retain the shape being given under pressure. This property is known as plasticity. But here what I am telling today, this is a process in which actually generation and movement of dislocation. Try to understand. If any kind of problem is there, so dislocation will appear. Now, if this dislocation is increased, it will result deformation. This is what is about localized plasticity. And number 5 is vacancy formation. It is very, very important. Vacancy, how vacancy is formed, you know. Actually, vacancy, how it is formed? Actually, vacancy is generated. Rather, it is a type of actually point defect in a crystal when an atom is missing from actually one side of the lattice, from one lattice side. I repeat, it is a point defect in a metallic crystal when an atom is missing from the actually one side of lattice, one lattice side. So during actually introduction of hydrogen, vacancy in the metallic structure will get increased, and it is difficult that these vacancies will be eliminated soon, as a result of which your actually metallic structure will become actually deshaped and deformed. So these are the different mechanisms proposed by so many people regarding hydrogen embrittlement. So what we have seen, hydrogen embrittlement is a phenomena when a metallic structure is exposed in hydrogen environment. It may be absorbed in the metallic structure. Essential component is that presence of hydrogen is a must. Number 2 was actually the metal or metallic structure being used should be actually susceptible to hydrogen, and number 3, the structure might have stress of any type, either internal stress or external stress. And if this thing happens, there are 5 or 6 different phenomena which are proposed. Actually, it is proposed that when hydrogen is absorbed on the metallic surface, this thing can happen. Either internal pressure, number 2 is metal hydride formation, enhanced dilution, localized plasticity, and vacancy formation, due to which metal or metallic structure will have various kind of actually problems, including brittle surface. As a result, it will become used and ultimately it will fail. Now we have to see how we can control this kind of corrosion. The best option to control hydrogen embrittlement is avoid contact between metal or metallic structure and hydrogen. We have to somehow maintain that. This is the best option. And number 2, if welding is required, if any metal or metallic structure needs welding, then we have to ensure that there must be pre as well as post heating. I repeat, pre and post heating, during which hydrogen adsorbed will be diffused out before it can start some damage to the metallic structure. These are the steps we can take to control actually hydrogen embrittlement. I think you might have understood. Today, another example I am going to tell you. This is all about your hydrogen embrittlement. Now let us see another serious kind of corrosion, that is selective leaching. By name itself, you can understand selective. Specifically, a particular metal will be leached out. If we actually talk about brass, you know it is an alloy of zinc and copper, as we know. Copper will be on and around 70%, zinc will be 30%. If alloying is not proper, sometimes it may happen the entire zinc will be selectively leached out of the alloy, and this is known as de-zincification. Then what is selective leaching? From an alloy, if a particular metal is selectively leached out from the alloy, is known as selective leaching. The best example is removal of leaching of zinc from brush. If anybody asks, how does it take place? Then we have to tell that because of poor alloying, this may take place. How can we control? We have to actually ensure that during alloying process, zinc and copper are properly alloyed, no compromise is made, then only this kind of selective leaching can be controlled. Today, this is all about your actually selective leaching. We have discussed 2 different phenomena. Number was hydrogen embrittlement, and number 2 is selective leaching. Please go through the video till the end. If there is any doubt, please note it down and we will discuss and clear your doubts in the next